I do work at the Armstrong Flight Center Research Center, and we are focused on aerospace, and so that is where our sign name comes from. My family is all hearing except for myself. I'm in this picture with my parents and my 3 older brothers. I'm the baby. And I have always been a tomboy, and I blame my 3 brothers who influenced me growing up. We love humor in our families, and you can see that in our family picture. We are emulating Princess Leia with her buns hairstyle in this photo. And my hair has always been short. I love it short, and I like to wear it that way. I communicate in my family. Well, let me just talk about my growing years. I didn't learn English nor ASL until the age of 9. And so before that time, we really didn't have a lot of communication in our family with me. It was a really tough time. And finally, at the age of 9, I was able to learn ASL, and there was a lot to do as far as learning ASL and trying to speak English and learn English. We tried simultaneous communication. My family was involved. They learned sign language, and they spoke with me as well. And they were very supportive and encouraging of my development. They believed that I could always do anything as long as I had the right attitude, no matter if it was challenging or whatever. And, you know, if I got in trouble, I was reprimanded and encouraged to continue on my path. So you might be wondering what I like to do in my free time, and I have a variety of hobbies that I like to engage in. I love reading. I love playing video games. I particularly care for the Switch video game. I am a quilter. You can see the quilts in this picture. The blue one I hand-stitched. It's a king-size quilt. Very big, and very proud of that project. I enjoy working with fabric and making it into something functional. I also like to do face painting. Both of those are mine, the skeleton. And then the tiger was not for RIT. It was the mascot of my high school. But it definitely fits the RIT environment as well. So do you agree? You agree with me, right? Yeah. And also I like to crochet. I just actually picked up crocheting. And that red monster I made for my niece who was recently born in September. She's still a little baby, and so I made the monster for her so as she grows she can engage and play with it. I love to bake cookies, and cookies I use as bribes to my coworkers to work better with me. No, I'm only kidding. I like to share the cookies that I make with people that I work with and my friends and family. Let me give you a picture of NASA. NASA employees do not work in one location. We work in many locations across the country. I am in the AFRC picture that is located in California. JPL is a little different, and I'm not going to explain it in depth, but just know that it's part of NASA, and ARC is also in California. Then in Texas, there's the Johnson Space Center, and then we have also locations in the other states, Alabama, Mississippi, Florida, Virginia, Maryland, and Ohio, as well as DC. NASA has a lot of collaborative partnerships with different properties around the U.S., and I couldn't even name them all, but just know that NASA is actually has a national presence. This is a picture of where I work at the Armstrong Flight Research Center. You can see the stone welcoming visitors as they come in, and we are actually on Edwards Air Force Base in the desert. That is where the shuttle lands when it returns to Earth. Let me see if I can show you. Right there is specifically where our buildings are located. And so the area, as I said, is desert. It's a dried up lake bed, and we work within those different buildings and the different facilities. I'm going to show you a short 3-minute clip that shows you what happened at Armstrong Flight Research Center in the year 2017. So the video just gave you a glimpse of all that we do, what we've done in the past year. And that was just, we had a lot of projects this past year, and there were some that weren't shown in the video. So it's a very, very busy and active center with many, many projects. And so one of the projects that I worked on was in the video, and I'll be talking about that later. So I was invited to participate in the ASL lecture series, and the ASL lecture series invites people to talk on a variety of topics that are listed here on the slide, and I will show you which topics that I will be engaging in this afternoon. I might touch on other topics as well, but these are the topics of my focus this afternoon. Anyway, here's a picture of the team that I worked on one of the projects with the G3. The G3 is a Gulfstream 3 plane, and it's the white plane sitting in the background. The Gulfstream plane supports different experiments at our center. Sometimes we need to do data collection, and so they'll use this particular aircraft to put the data collection devices within the aircraft and collect the data for a particular research project, and then it's handed off to the research team. We call ourselves SCRAT, which stands for subsonic. Let me see, SCR, Research Aircraft Testbed. So that is what SCRAT stands for. And subsonic provides the S and the C for SCRAT. Here's an example of one of the projects and the experimental projects. If you look at this, this is a conventional flap on an airplane, and if you look at the flap, you'll see as part of the flap moves, there is a gap between the actual wing and the flap. And it's aerodynamically not the most efficient type of flap. So within our research project, we modified the flap, and if you look at this particular section of the flap and over closer to the fuselage of the plane, you can see that there's not a gap when the flap is engaged, but rather it's like a modular piece of material that flows, and so there is no gap when the flaps are engaged. And we tested it to see if it improved fuel efficiency and flight efficiency as far as speed as well as noise reduction. So for this particular experiment, as I mentioned, we were focusing on the flaps. The name of the flap that we design is the ACTE, which is the Adaptive Compliant Trailing Edge. And we call it the ACTE, and its name is on the top of the slide. If you, well, don't ask me to say it again because I'm just going to always say ACTE from here on out. And that's what we do on base as well. We just call it the ACTE. We love our acronyms at NASA. So that's one of the experiments that I was involved in. And a second experiment is this particular one. It's the acoustic research measurement. And so we call that ARM. And I would not sign a human arm. I would fingerspell it every time. But sometimes interpreters who come into our center hear the word arm and they think that we're talking about the human arm, and I have to ask them to fingerspell it because we're talking about this specific research project. So English can be a very confusing language with its redundant meanings for specific lexical units. Anyway, with this particular experiment, we're focusing on the landing gear, and there are ACTE flaps on this particular plane as well. You can see the continuous edge of the wing without the gaps in the flaps. And now focusing on the landing gear, we're focusing right there in the front of the landing gear. And it's a little different from a regular landing gear. On the right is a regular landing gear, and then on the left we added a fairing. And that's the component that's covering the leg of the landing gear. It's called a fairing. It's, if you're familiar with motorcycles, you know when you look at the body of a motorcycle, there is a windshield, but also there's a cover between the bike and the windshield. And if you didn't have that, when you were riding on the bike at very high speeds, the rider would be hit with a lot of wind. It would be noisier, and it definitely would not be fuel efficient nor aerodynamic. So the fairings help with the airflow over the vehicle, and that's the purpose of the fairings, to make it more efficient as it travels through air and space. So applying that concept, we're applying it to this project. The conventional landing gear has a lot of moving parts, and the parts interfere with the air movement across the landing gear. But with the fairing, the wind and the air can move over it in a more efficient manner. And ultimately, we want to see if there's noise reduction as well. Now, there is a local community near the Edwards Air Force Base, and many people in the area have complained about the noise of all the equipment we have taking off and landing. And so most of the noise is caused by the landing gear. The wings don't produce a lot of noise in air, but it's the landing gear that causes the noise from the airplane. And so we would like to become more green, reduce air pollution, and reduce noise pollution if we can as we continue our work. And so that's what this project is about. And this was the first project that I worked on. If you can see in this picture, there is an array of microphones. And we set them up out on our test bed. And what we wanted to do was to test the noise within the lake bed. And it kind of looks like a sun. And so what we did was we had planes come in and fly out at very low altitude across the microphone array, and then they circled around and did that continuously. And we did it with the fairings on and with the fairings off. We used conventional wings, we used the ACTE wings, so we changed a lot of the variables. And we did all these tests within a day and did all these flybys. And gosh, we did it many times. And we just did it all day. And we collected the data throughout. Now, I'm not a data analyst. I collect the data and then I hand it off to the other research team to do the analysis. And as they do their analysis, they may want more things tested. And as they do, then we do more data collection. So that's where I am. I'm looking on projects and doing measurements and collecting the data for NASA. This shot was taken from a helicopter. It looks like a helicopter, but it's called an octofer. And what it is, it's a vertical flying machine. And what we did was we had to calibrate the microphone array before we could do our testing. And so we used the octocopter. I don't think the interpreter is pronouncing it correctly, but it's OCT instead of helicopter. We use that. Now, let me talk about my role in SCRAT. You can see on the right side of the PowerPoint, there is the SCRAT, the rack array. And what I am working on specifically is called instrumentation. And so the rack is holding the different systems and sensors that measure a variety of variables. It could be airspeed, air pressure, temperature, whatever variables need to be tested, we put sensors in and around the plane to collect that data. We, through a voltage system, collect the data. It converts the data into binary form, and then the instrumentation then will save the data in a file, basically. And while it is doing that, at the same time, we are using something called telemetry, which is ground-to-air communication. And so while this is all being collected, on the ground we can collect the data simultaneously. And so we work with the telemetry system, and it saves the data in flight as well. And so sometimes the telemetry system breaks down because the signals don't connect. However, the data is still collected on board, and when the actual plane lands, then we have that data file and we can send that on to the research team. I focus mostly on software, and you can see on the actual computer monitor the colored text that's showing the work that I did, the program that I created, and then the black box is another piece of equipment that if we take it off, we can engage it or disconnect it, and the code then is delivered to the computer through that black box device. And then I interact, like I'm a software manager, and then there are other software managers. We have different roles, and so I'll interact with another software manager to discuss what software needs to be installed on the flight and what research needs to be collected. And so I'm a software manager, I do instrumentation, and I make sure that all the data is collected accurately.
So the second project that I've worked on is this low boom flight demonstrator. And we call it the LBFD. This plane is not produced yet. It is still in concept form, but this is the idea of what it might look like. And maybe you're wondering why we need to create this new plane. Are you all familiar with the concept of a sonic boom? Maybe you have experienced feeling one yourself. Anybody? One person has? Maybe two people, okay. Well, I've experienced it 4 times in my area. It's rather frequent. So the sonic boom is of concern. A lot of people are really interested in having faster flights. Are you all interested in that? I mean, a lot of times if you want to fly from New York to California, you have a 5 or 6 hour flight, and nobody really enjoys that. You would prefer to go a lot faster, but that's not allowed actually, because the speed of the plane will cause a sonic boom, and it is really annoying to the communities down on the ground. And so what we're trying to do is to create a low boom. I don't think we can completely eliminate the boom, but we can make it quieter. And it's possible that someday a plane like this will exist. We're in the beginning stages of this concept, and we're trying to figure out who we may possibly partner with. But for now, one of my responsibilities is in the instrumentation system. I'm the software lead for the instrumentation system. And so I'm like a type of a boss, but I am responsible for the software instrumentation system in this plane. So this picture here shows where the system will be attached. We're not going to first build the plane and then just add on this software instrumentation system because it's may get lost. we need to first plan for the right size and make sure that it fits within the plane. So hopefully you have noticed me using some technical signs, and you notice that I do spell some vocabulary that we use frequently in my work. And maybe those signs will help you in your future work or in your current work. I'm just going to tell you a little bit about my experience as a deaf engineer. Alabama does have a deaf employee. Maryland also has a deaf accountant working for NASA. I'm sure there are more that I just don't know about, but they're all female. I do a lot of working with my teams as a deaf person, and I'm going to talk about my challenges and the approaches that I use when working with a hearing team. As the sole deaf engineer, now I did mention that there are 2 other deaf people. There's somebody who does some schematic drawings. They're like blueprints for an airplane. So there are, and a female accountant, and so there are 3 in total. But I am the only deaf female engineer. On the top of the screen, you can see this, like, how to work with deaf people for dummies, and it's a presentation that I gave to my coworkers and my boss. And I asked permission to give this type of workshop so that everybody would know how to work with each other, and my boss gave me complete permission to do this. I noticed a lot of people really were interested in what I had to say. I used a lot of humor and cartoons and comics in my presentation, and people really opened their minds and became more comfortable with working with me and approaching me and having conversations with me. We talked about having to figure out different ways of communication. In my office, I have 3 giant whiteboards that we can use for communications. I have a lot of different colored markers, and so people now feel welcome to come in my office and know that they can use the whiteboard to communicate, or email, or Slack, or instant message. We have a lot of different communication options available to us, so my coworkers have been very positive in this. As the only deaf woman engineer, I see my graphic up here, 2 men, me, and then another man. So the ratio is 3 to 1. There's a very small group of female engineers, very small pool of us among many men. So I'm going to share a couple stories that I've experienced. Which do you want to hear first? The bad story, negative experience, or the positive experience? There might have been a few more votes for the negative experience. So, like I said, I'm the software lead. And during meetings, we often sit around a table and talk about our projects. And one really cool thing about NASA is that sometimes you might have, that one person that you work with that, everybody else is really awesome, but that one person is just difficult. And I think it happens in every organization. I'm sure that you've all experienced it too. There's always just that one person that you can't get along with or just doesn't want to try. And so I had that same experience on my team as the software lead. So the instrumentation lead, who was also my boss, we were just having a conversation, and this one guy that was difficult to deal with, he was talking to my lead and saying, there's this problem with the software and I can't really resolve it. And my boss said, you should talk to Johanna. She really knows what she's doing. She's been working with that software. And I nodded my head. And the next meeting, that same guy said, I'm still having this problem. And the lead said, you really need to talk to Johanna. She really knows what to do to solve your problem. And I nodded my head like, yes, I do. And this person was a white man. And he went back to the lead and said the same thing again. And he had the same response and said, you really need to go to Johanna. And so he finally did, but fixed the problem without consulting me. He went directly to my lead. So he wasn't really willing to talk to me as a female engineer. He didn't think that I had the knowledge to help him, and I was the software lead, but he went over my head to the instrumentation lead, and I just consider that completely rude and unprofessional. It really rubbed me the wrong way. I asked one of my other female coworkers about him, and she said, he's really only I've ever associated with the guys in the office, and he rarely asks the women for anything. And he's just not receptive to any feedback or advice. And so I heard that he wasn't a very good engineer either, and so I was just advised to avoid him. I do still need to deal with all of that kind of thing, but we figured it out. There are ways around it, and we got through it. I did notice that my lead was really frustrated with him too, so it wasn't just me, and things can improve. So that's my negative experience. Now on to my positive story. Now, working in the hangar, so it's not a garage, it's a hangar. Make sure you use the appropriate classifier if you're an interpreting major. Also, when you hear the word vehicle, we're really talking about planes. So make sure if you're in this environment, when I say vehicle, it means an airplane. So I was in a hangar working on a plane, checking the instrumentation. I really do work on planes. And I was fixing the system. And I don't touch any of the wiring. We have technicians to do the wiring. We have very separated roles. We have our own roles that we do, and we don't step on other people's toes. We were doing some calibration. And I came out of the plane. The technician and I wasn't paying attention. Neither one of us were paying attention. And a wire went flying and hit my leg, and I didn't think anything of it. And I said, "It's no big deal." And he said, "What are you doing?" But he was picking on me. He was being funny. And he was like, "What are you doing?" And I said, "I'm watching you." And I said, "Come on, ladies first." And he said, "No, not here, not at NASA. Everyone is equal." And I was like, okay, I'm not going to start a fight or anything. So everybody laughed. And then the next day, I was back in the hangar for something different. And I needed to go in there for something. And that same technician was there. And he said to me, "Ladies first." And I said, "No, not here at NASA. Remember, everyone is equal." And he said, "Oh, yeah, you're right." So we were teasing each other. And he was very respectful. But it was a good reminder that everyone is equal at NASA. But I just wanted to share that nice, positive, funny story. You notice the mobile apps, the interpreting apps that I have there. I didn't put this in the accommodation slide because as the only deaf engineer, the two other deaf employees are not engineers. They have desk jobs, and they have stationary video phones at their desks. And I'm all over the campus, and I may be in one building where the VP is not working, and we're not able to make a 911 call, and I would have to use a phone. That doesn't really work out well, right? So I was allowed to use my personal phone, And in the beginning, IT did allow me to connect through the NASA Wi-Fi system, so I could use the video relay service. It was blocked by their firewall, but I did work with NASA to allow my personal phone to get through the firewall to access the service. So they did provide that accommodation. And then later on, personal phones became completely banned from accessing the NASA Wi-Fi system. And so one day I just couldn't connect, and I didn't know why. And so I asked the IT department, and they said, well, there's new policy, but we could make an exception for your personal phone again, but they just decided that they would give me a NASA issued phone. And so now I have two phones. And so sometimes I pull out my phone and realize that's not the one that I need to be using and I need to switch. But it works out a lot better because I have a better connection. And the IT department was very willing to work with me to provide that accommodation. I know that they had to figure it all out for me, but they did give me an IP address on that phone, and it all worked out, thankfully. I know that it was challenging for them to get it all worked out, but they did. All right, whatever you want to sign for accommodation, that's what I'm going to talk about now. I could go on and on about interpreters, but I'll try and make this short. I work in Southern California, and the surrounding area is the U.S. Air Force, the U.S. Air Force base. So I use the sign USAF to represent the Air Force base, and we are right in the middle of that. The Air Force has a staff of interpreters, and we historically borrowed from them. But one problem that we faced was that we would have a meeting and the Air Force would also have a meeting at the same time, and they would trump my request for an interpreter. And we were trying to figure out a way to schedule that better, but we all realized that we should have our own interpreters. It doesn't really save us any money. We didn't want to risk not having access, and so we did use some freelance interpreters, but that was very difficult because the interpreters are primarily in LA, and to get to the base is about 80 to 100 miles from Los Angeles, one way. And so round trip, it could be 200 miles for an interpreter to travel. So, just imagine the interpreter driving an hour and a half, roughly. And if there's traffic, it could be a 3-hour drive one way to interpret for an hour. And NASA does not doesn't pay for travel time. So it's not really worth it for the interpreters as freelance interpreters. We did try some video relay interpreting. I needed a laptop, which was very difficult to carry around to all of the different buildings that I work in. And it's an engineering laptop. I was carrying that around. So I asked for an iPad. But with VRI, you get a different interpreter every time. And so I would have, if I'm explaining one of my projects, I'm using this technical sign. And can you imagine having to explain yourself to every single interpreter you see every single time you need to have a meeting? So VRI didn't really work out. And every once in a while, the Wi-Fi signal would not connect, and there would be a delay in the interpreting, and so it didn't work. In the Lange Research Center in Virginia, I found out this information through a deaf person, that they have their own interpreter who works in 3-hour increments throughout the week. And it seemed like we would be able to borrow that interpreter through FaceTime or Skype or something. And during their 3-hour window of time, we can borrow that interpreter. And that interpreter has been working at NASA for quite some time and has the terminology. And so I thought, this would be great. The challenge is the interpreters can't see what's happening in the room. And also, there are a variety of vendors competing to provide the service. And so that led to an in-house interpreter position. Now, it would be half secretarial, half interpreting. And I know some of you are like, that's a conflict of interest. And I know, and I agree, but it's government money and we need a reason to support the position. So it's going to start as a half and half position, half secretarial, half interpreting. And then as the need increases, there may be more interpreting. Or if we hire more deaf employees, there may be an increase in the interpreting need. And so maybe that half-half position eventually would become a full-time interpreter position. So it can grow into the full-time position. So that's our goal, and it's in process. I do have an interpreter currently, but this full-time position is in process. Now, interpreting aside, I just want to talk about some captioning. You saw the video I showed. They did add captioning for this video, but because I kept asking for it, and every time I asked for it, they said, yes, oh yes, we remember you, and so now they definitely know who I am. We have these TWAN meetings, which is this week at NASA meeting. They're released on YouTube every Friday, and they just give everybody an idea of what's been going on throughout the week. So my first week of work, I thought, hey, this is cool. There's this video on Friday, but I didn't see any captioning. And so I emailed the person that I was supposed to email and asked them to add captioning, and they did. And then the next week when the video came out, there wasn't any captioning. And so I, again, asked for it. I said, remember, can you please caption this? And it took about 2 or 3 months for them to remember, but I've been working there since 2014, and they've been captioning it ever since I started asking. I just needed to remind them a few times, and now it's automatic. There's also DVDs that they caption. Sometimes Armstrong will have some speakers come and present on their research or their expertise, and they record those presentations and they save them on DVDs for later. Sometimes there isn't an interpreter available or I'm not available, so they'll record it onto a DVD for people to watch at another time. And I'm trying to think, there was one program, a speed training program that I needed to take part in, and there were several DVDs, and so I asked for the DVD. They gave me this pile of DVDs, and I started to watch, and I watched for a while, and I saw that this little sound bar was moving, so I realized that there was somebody talking, but there was no captioning. And so I emailed the person who had given me the DVDs and informed them that there was no captioning. And they said, okay, give them back. We'll figure it out. They captioned the DVDs, but it still didn't work out. The programming didn't work quite right. But it eventually did. Found the right program to use. And the captioning was there. I mean, before I was hired at Armstrong, there were only 2 other deaf people that had worked there, and they weren't very aggressive in asking for their needs to be met. And so I think sometimes maybe that people are fed up with me asking for things, but I don't feel guilty about it. I know that Well, maybe many of you know the article about me. There's a picture of me in the control room. Have you seen that article? That article was published in April. And one of the people that was part of the video, the DVD video, happened to see the article about me, and he emailed me and said, "Hey, I saw the article about you, and it was all about how you've navigated through your barriers, and it's all because I just lit the fire, and I got their feet to the fire, and I got them interested in doing it, and so now it's automatic." And I can joke with them, but at the same time, I'm serious. And people applauded my efforts. So sometimes maybe you feel like you're asking for accommodations and people resist sometimes. You have to remind them that it's really important to work together. And people aren't always going to be resistant. But just that conversation and the article and the struggle made everything I did worth it. Now talking about some of my coworkers, I did have a little negative story, but we just use a lot of humor at Armstrong, and we feel like a family there. A sense of humor is really important for everybody to have. We do take our work seriously while keeping it humorous and keeping it light. You know, like we have little jokes, inside jokes that we share as well. We communicate through my whiteboard system in my office. We use gestures. I did teach some ASL classes 1 day a week until we got more busy with our projects. But some of my coworkers are remembering some simple phrases and finger spelling, and that helps. We also use Slack. Sometimes we use text. If I absolutely need something, I'll text. But, you know, some people are learning some basic signs, and people will ask me, you know, what's the sign for you're late? And so the next meeting, if I'm 2 minutes late, they'll sign to me, "You're late." And so they use it in humorous ways. See the picture in the top right? That's me in the middle with the 2 projects that I'm working on, and each one is jockeying for my time and attention. I really should put half of my attention toward each one, but currently my time is needed in the SCRAT project. But there's going to be a flight schedule coming up soon, and so the instrumentation needs to be ready. So my other project is being put on hold, but they're fighting for my time. I mean, I guess not fighting, but they want my shared time. And so eventually I'll have more time to give to the other project. Now, both project leads want the expertise that I have. They're very supportive. We have a really good team, and they are strong allies. If we notice that there's been a concern or the interpreters are struggling, I can always express my concern to my boss. And often it's not just about me. It's a team issue, and everybody is involved in the resolution of that. And sometimes I alert them to a problem, and it's taken care of. And see the cartoon with one stick figure pushing the other in the water? You know the concept of sink or swim? You know, it's just forcing you to try something to see if you succeed or if you fail. Now, what do you think my lead would do to me? I fell. I'm the person falling, and my lead is the person pushing, because he really wants to see that I'm a quick learner and that I can trust myself to learn. And so he really pushes me into a lot of new projects and a lot of new work, and he trusts that I can figure it out. And he often will throw me a little raft or a life vest or something. If I need a little bit of help, he'll provide an explanation or just a little tidbit of information. And so far, I've been swimming. Sometimes I really feel like I need a life jacket, and he'll throw me one. Sometimes he'll throw me another one. Sometimes he'll throw me one more. But so my lead is very invested in my growth, and he expects me, even as a deaf person, to be equal to my hearing colleagues. He expects me to function the same, and he knows that I can function the same as my hearing colleagues. So I'm involved. He supports me. Even if there isn't an interpreter, he still encourages me to be there.
I'm just going to briefly talk about technical signs at this point. If you've noticed during my presentation, NASA just loves acronyms. And so, as I said in the beginning of the presentation, the word ARM is an acronym, and so it should be fingerspelled and not used as a technical body part. And so the acronyms, we have a dictionary of acronyms at NASA for the common acronyms. I couldn't include them in the project, but there's a separate dictionary. It's incredible the amount of acronyms that NASA uses. So, the challenge is standardization for technical signs is not something that has developed within American Sign Language. There are dictionaries of signs, but none of them really technical or in the STEM areas. And so typically what I do, again, as the lone female deaf engineer, there aren't any other deaf engineers in my vicinity or in my network. And so I do think conceptually, what do these concepts mean? And I ask for people to tell me what their opinions are, but an engineer's brain is different than brains from other fields and other perspectives. And so we really do need a cohort of deaf people who are in STEM fields. The community needs that to develop some more standardized technical signs in STEM. Also, I am not an expert in everything. And so you can see that in the graphic that says, hello, I'm not an expert. And so, new words that come to me, I might understand, say, for example, structure in general as the lay definition, but I don't understand its variety of uses in technical fields. And so first we need to conceptually understand what its use is, how it's being applied in the language, and then we can figure out a sign for it appropriately. And really, we really need the community to be involved in that. And by the way, like for example, I figured out the word aerodynamic. And there really wasn't a sign for it, but I thought about it and how it was applied at our center. And I realized that we're focusing on air vehicles, on planes, and that type of vehicle. And it talks about airflow and how it moves through the air. And so I created a technical sign for aerodynamic that I use at my center. When I am in the presence of other deaf people in STEM fields, I'll ask them their signs, but that's the sign I use for now. So the danger isn't always creating a sign just in the spur of the moment, and expanding on signs as well. And so let's look at this graphic. I'm not going to explain everything. I'll give you a minute and look at the labels under the actual words. The labels tell you what its role is in the plane. Question, do you think all airplanes are set up exactly the same way? Who says yes? Who says no? Okay, the no's have it. So I have an example. Here are 3 different aircrafts that are set up completely different. So the Scrat airplane is in the upper left, the G3. And you see right there in the tail section, right here horizontally, you can see it present in the front view. Many planes you can see this configuration in the tail. In the G3 it's actually this other configuration where the elevator is at the top. So you can't just assume that the elevator on the tail section is at the bottom of the rudder, that it's actually at the top. Now, the X-29 airplane's wings are forward facing. They're forward wrapped wings. They're forward swept wings. And in the G3, they're not. And if you look at the X-29's elevators, they are near the back of the plane. And I want to show you also on the LBFD plane where the elevators are. They're hard to see. I'm pointing to them right now with the red pointer. You see these little tiny wings that are on the top of the tail rudder. They look like wings. Many of the aircrafts you'll see just have one tail rudder or one elevator, but in this particular LBFD X plane, it has 2 smaller ones. And I'm not going to go in depth about it, but this particular plane actually has 2 sets of them. There's a bottom set and a top set, and I'm not sure exactly which controls what. I think it might have some control for the plane, but I think it's actually trying to reduce the sonic boom. It has something to do with the sonic boom and that effect, and there's an attempt to reduce the impact of the sonic boom, but I'm not an expert in that area. But I was told that it was a shape boom, and so it was used for the sonic boom, and it has that function. So the takeaway from this is, yes, each of these devices functions in a similar way on each of the aircraft, but positionally they are set up different and they look different. And so you really need to know what you're talking about, and it's not just a label, but you need to know the whole description. I'd like to talk about conceptual accuracy with signing. So one time someone was sitting in the cockpit looking at the instrumentation, and you can see the graphic of the pilot in the cockpit. And he's sitting on he has the yoke. He's driving with the yoke in the airplane. And then there is this device on the wing, which is a separate instrument. It's called an inclinometer. And so that was attached to the wing. And so that was on the wings, and then we had the person sitting in the cockpit, and we wanted the person to change the yoke in degrees, and we wanted to see what the number was, and we wanted to collect that data to make sure that the instrumentation was calibrated correctly. And so that's what we were basically trying to do, was we were doing a calibration process. Let me say something about this instrument on the right. It is used for calibration, and it shows the specific position, whether it would be a down position, a neutral position, or an upward facing position. And you pull the handle, the red handle, away from the black body of the device in order to set up that calibration. And so the process looks like the lead will talk into the headsets, and the lead will say, okay, 1/4 to the left, meaning that the yoke and the pilot yoke needs to move to the 1/4 position in a leftward direction. And then numbers are given as it does that, and then it would say turn left, and so we turn left, and then the numbers are then given again. And so it's a process of data collection and measurement charting throughout. Now, the technical sign for this conceptually would be 1/4 turning to the left, but from whose perspective? Is it from the signer's perspective or from the viewer's perspective? And if you're not clear on that, that can cause some confusion and misunderstanding. So if you say 1/4 to the left, but I'm reading it as 1/4 to the right, we'll have bad data fed into the system. So I think specifically for this particular example, you have to use the sign left, either spell L-E-F-T or use the sign left, initialized L, to make sure the person reading the finger spelling is left. There's one funny example. We were doing a data collection protocol like this, and one person had the headset, and one of the other people who was working on the data collection was hearing but didn't have a headset, and so instead of he couldn't hear over the headset, and so one person was on the one wing and the other person was on the other wing, and so the person with the headset was writing the number, and the person without the headset was looking through the two windows in the airplane onto the other wing to get the number from the person with the headset. And so they were peering through the windows and struggling, and I was in the plane watching this go on, and I could see the numbers. And then my lead looked at me and he said, "What?" He said, "What's the number?" And I looked at the number and I told him the number, and he said, "Okay." And so rather than looking through the two planes of glass through one side of the window and another, I was part of the communication system, and they didn't have to do that laborious data collection because as planes age, the windows fog up and it's not seeing clearly through glass. And so it was a labor-intensive process to just figure out what numbers we were collecting and what data we were logging that day. So, the control room. As I mentioned, last April, I was put in the control room. It was the first time for NASA to have someone like me in the control room. I was at the Flight Support Center, and I had an interpreter working with me. You can see the interpreter in the bottom right-hand corner on my computer monitor. And you might wonder how that happened. And prior to me being in the control room that day, many people thought a deaf person couldn't be in the control room. But, I wanted to be in the control room. And my lead, when they were getting ready for the flight test, said, I think we need you in the control room. And I was surprised that that would even be told to me, that like he already had expected me to be in the control room. He didn't think about a barrier that I couldn't be. This particular individual was like, we need Johanna in the control room. We need her expertise. And he said, we need you in the control room. And so I explained that, well, we need to figure out how to fit an interpreter in the control room as well. If you look at the control room setup, the setup is the computers are on elevated platforms, and so they're even higher than normal. And so if we're going to have an interpreter physically put in the control room, they would have to be on some type of a riser, and that would be too high, and the interpreter wouldn't really fit next to any of the computer monitors. And so we figured out a way to set it up on the computer monitor, and people were very engaged in figuring out how to resolve this. And so we did some testing within the control room, and then they asked for my feedback as we did this testing, and I gave them feedback like, where you have the interpreter positioned on the monitor doesn't allow me to see this information that I need, like time, etc. So we made some modifications. And then, of course, there were some people in the control room who were resistant to this idea. Just like in any organization, you have people who are resistant to change. But my lead was really impressed with the way the people who were running the control room, and sent them some letter of appreciation, and gave them props for what they had done. And so that information got passed on as well. And so we worked with the interpreter. We could see that information then got sent to the EEO office, and the EEO office got involved, and people were very excited that at the beginning, what seemed to be a problem worked into be a great solution. The other people in the control room who were resistant saw that it actually worked. And in the end, it was a very positive experience. And it needed to be a positive experience to see what they could actually do. So it was very supportive, and in the end, very positive. And it did happen because, yes, I'm a deaf individual, but I had a hearing ally in my environment, and we had the never give up attitude. And so when I look at the culture of NASA, they don't really look at access as a problem that I have. It's a problem that NASA has. And they look at the problem as to how they can solve the problem that the group has in NASA. And so now it's not Johanna's issue, but it's the group issue. And NASA likes to try, and they approach issues by try, test. If it fails, you try again. That you can only come to a solution. So if you fail, you just learn something and then apply a new solution until you come to resolution. And so I do love the attitude in NASA. I love that NASA is filled with people who like to solve problems. So with that, I am done with my presentation this afternoon. So thank you. Thank you so much. And do we still have time for questions? Yes, we have 5 minutes if people want to ask questions. The interpreter, Carolyn. Carolyn will copy sign your questions, and I'd be happy to answer any questions that you have.
What is your educational background?
I have a bachelor's degree in computer science. I don't have a master's degree at this time. More? Yes?
My name is Paula.
I remember you.
I had class with you yesterday.
Yes.
I have a question for you. Why Minnesota for college? Why not RIT?
Well, to think about it, I was thinking about Gallaudet. That was in liberal arts college. And then I thought about Rochester. And I thought, 3 semesters versus 2 semesters. So let's see, it'd be 3. And then would I lose credits? Were they changing the calendar at that time? So I was wondering if there was going to be an issue with me losing credits. And I didn't want to risk it because I would have been a student when they were transitioning over to semesters and from quarters. And so I was thinking ahead and thinking in the early term. And Minnesota had a large community. They offered me good scholarships. My brother was 30 minutes away, so if I needed anything from food to a place to crash, place to play games, I could always go over to my brother's, and my parents, would help out with him taking care of whatever my needs are. So that's why I picked the University of Minnesota. Yes?
Why did you change from computer science to electrical engineering? Were you able to use the skills you had from computer science and apply them to the electrical engineering field?
Some transferred. There's one thing that you might not like. Sometimes you major in something and then you think, when I get a job, that's exactly what I'm going to do. But you know what? The world isn't like that. And so I do have aspects, I would say, that I can apply computer science in my work. And then there are other things that I had to learn. So I do computer science, I do software, but I also am engaged with hardware. And so I had to do a lot of the electrical engineering type information. I really am not, I do not like physics or any of those theories. electrical engineering theories. I don't gravitate towards them, but I needed to learn them, and it was part of my job, and my mentor was there to guide me through it. And I have to say my mentor did a great job explaining the theory, I would say better than a lot of my course teachers could. And when you have theory and application, that is helpful. There was one theory that was explained to me, and they explained it and expanded on it. And then I asked them to give me an example, and they go, well, really, it wouldn't work in the real world. So sometimes they kept it simple, but my computer science degree actually does apply to my current job and how I'm working with the software. And if there's an error, I will check on the computer science side because it might be a bug in the actual code. So it is applicable, but I had to learn new information on the job as well.
This is Paula again. So as a deaf female engineer, what have you been most impressed with your time at NASA?
So what do I most identify with? Is that your question?
Meaning, like, what do you identify most as? Because you are deaf, woman, engineer, what in a male-dominated field, what do you closely identify with?
Oh, I see what you mean. That is a tough question to answer because I am deaf female. I've got both of those identities within me. I can't really separate them out. I think working in a hearing environment that I'm deaf first and that I'm a woman second. I think people are impressed with the way I am creative. I'm creative with my communication, and I'm creative in the way I approach problems and solve them. So it's not looking at my hearing status, but it's looking at my abilities. And so, but I think I'm deaf first there. At this one meeting, one person made a comment, and the comment was, I hope in the future, that they were asking about interpreting what it would look like in the future. And, you know, we experiment a lot, and we were talking about experimentation. And, you know, they said, I hope in the future we have 50 more deaf engineers, meaning they wanted to see more deaf people. So they're impressed with my level of expertise as an engineer. I work hard and very focused. So I hope I answered your question. Any other questions? I just want to make a short comment. I have some NASA stickers, and you know the baseball card style. Instead of baseball card, it's a baseball card style, but it's a NASA thing, and so it's kind of Rosie the Riveter type thing. So if anybody wants one, child or adults, there is no age discrimination at NASA. So if you would like any of our swag that we have up here, you can feel free to come up and take it. Thank you for your time listening to my presentation as it went on and on. I hope you enjoyed it, and I hope you found it beneficial and got a better picture of what life is and at NASA, and maybe you were inspired as well. So thank you for your time and attention.